No, we haven't even technically gone over U sub. Does that make sense? Like we haven't even really done U and DU. I mean, we did a little bit. The crazy integration, or not crazy, but the intense integration, and some of it the new integration. Haha, next chapter. Can't wait for chapter 7. Then we can start having some fun. But no, in a good way. Like, oh, this is new. We've done a couple of those, but not like in super big applicable ways, at least as far as the AP. But number 1, 2, and 3. Watch out for your Riemann sums, for your trapezoidal rules. Watch out for what was the big thing and why do I like this table compared to some of the things you guys see in homework. What was true about the bases? Yeah, they're different, and that's like the AP. It's not going to necessarily give you the same, so you can't just shortcut it in some rule. Now, I did shortcut and pull out a 1/2, but why did I pull out a 1/2? Yeah, every trapezoidal area has a 1/2 in it, but all the bases were different, so I had to actually write them all out. And you guys got the formula for number 2, right? To get to a final, it's an initial plus a change in. Are we okay on that formula? So that's why I was able to do f of 8 was equal to f of 1 plus the integral from 1 to 8 of that sine cubed. Oh, there's supposed to be an x there. Sorry, don't judge. And then letter C, what was the formula we were using for needing to think about the minimum, aka needing to find the critical numbers, aka needing to find the derivative? How do you derive an a to a u of an f of t dt? Plug in the u, f of u times u prime. There you go. All right, number 4, what have you guys done so far? Catch me up. Well, we can just do it one long line, right? And then just stick it to the man. So if it's 4 equal subdivisions and we're going from 0 to 2, what are my x values? Nope, that's not right. Sorry. I'm not right. I'm right. You're right. So it's 0, 1/2, 1, 3 over 2. Good. Or just 0.5s, right? 0.51, 1.52. If there are 4 equal subdivisions, my base is going to be a half. So can't I pull out a half times a half times, right? Cool. Wait, to approximate f of 2. Now, they're super nice in this one. Probably they shouldn't be. But to approximate f of 2, wouldn't it be f of... Careful, is it plus or minus? Plus. Because it was minus and gets added to the other side. Initial plus change. And then from 0 to 2, right? Yeah, so what's the trapezoidal rule approximate? Good. The integral part. So if f of 0 was anything... Wait, what is f of 0? Yeah, and what's 0 to 0? Okay, so we're lucky because it just happened to be 0. But if it was anything, if they gave us a point and we didn't incorporate that, we'd be in some trouble. So 0 plus 1/2 times 1/2. Here's our trapezoidal rule, approximating the area, hence approximating f of 2. 1/2, pull out all the bases. Height time. F of 0, so sine of 0, right? Plus, why am I writing a 2 sine of 0.5 squared? Good, it's going to go with the trapezoid, and it's going to go with that trapezoid, right? Since it's equally spaced, I'm like squishing all my heights together. Because if you guys notice up there, wasn't the 30 used twice and the 40 used twice? I just couldn't combine them because one had a base of 3, the other had a base of 2, the other had a base of 1. So what else is going to have a 2? All the other 3? No, not the f of 2, but everything else. Oh, why am I putting 3 halves? 1.5 squared. If you wouldn't mind passing it out, I'm sure you can make their day. Aggie's going to trick or treat. We had leftovers. Yeah, you should, but... Oh, you don't have to literally. Here. Yeah, that's what I was going to do. Here, I'll take some, you take some. I get that started. There we go. Kathy. Carrie. Isa. Aryan. Naomi. Daniel. Sally needs one. But I heard a rustle, and I was like, we'll share. We're good. Riley and Hannah, you missed out on Kit Kats. All right. What do you guys do for letter B? It's a good day to come take a test in my room. I want interval or intervals. Is F increasing? F increasing. What do we have to think about? Uh-huh. Mm-hmm. Mm-hmm. What's the derivative of an integral, of an accumulator? Sine of u times u prime. Wait, why is u prime 1 and not 2x? In the bound, it's just an x, right? Look here, we look here. What, kid? It's not unit circle. I'm being a bum. If it's not unit circle, you should be good. If it's unit circle, you should simplify. So equal to 0. Oh, that's nasty. They would not do that. Infinitely many? Oh, wait. 0 to 3. Whew. That's good. When is sine 0? Why was I starting to freak out? Sine 0 at and I'm setting x squared equal to all those, right? But where do I stop? So where's 3? I'm square rooting stuff, true, to get to x. Square root of 0 is fine. Square root of pi. Square root of 3-ish, that's fine. Square root of 2 pi. Square root of 6-ish, is that okay? Why am I going to come here and then all of a sudden say, whoop, I'm done? Because 3 times pi is more than 9, and more than 9 is more than 3, square rooted, right? We have to be able to do at least a little bit of mental math. So now what? Does that make sense? Wait, how are we supposed to figure this out? This is hard, right? Yeah. So if you plug in, what's something between 0 and root pi?
Less than 1. It's like 1.7. It's like a little more than 1.7.
Square root of 3-ish will be 1 point something-ish, and what's like a unit circle value that I know that's 1.7-ish? Where is that? Is that first quadrant, second quadrant? Wait, it's somewhere first or second. What sign? Positive in both. Oh, does that make sense? Right? Okay, what's in between square root of pi and square root of 2 pi? 0's here. 1's here. Square root of 6-ish would be 2 point something-ish. Yeah, 2 point something-ish. So 2. 2 would be in between. What's sine of 2? Something positive number, because isn't 2 less than 3.1415926? Second quadrant, sign is still positive, right? So first, second quadrant-ish. Now, what's going on here?
Wait, why is that opposite? Why is it just opposed?
Oh wait, no, that's still first quadrant, because it's less than 3. It's like,
Always increasing.
no maximum.
Wait a minute, are we okay?
Yeah, it's always increasing.
We're not okay. What were you guys not doing?
Squaring. Oh, baby.
Are you kidding me? We just wasted that.
No, we're good. You just, when you plug in, we're plugging in and squaring it, right?
That changes the number.
So if we plug in pi and square root of pi and square it, that's sine of pi. What's something before sine of pi? First, second quadrant, good. But hold on, if we plug this in, sine of 2 pi, what's in between sine of pi and sine of 2 pi? Third or fourth quadrants. Oh, and then plug in something in between. What quadrants are we in now? Well, 3-ish, 9-ish, 9-ish, more than 2 pi-ish, but not quite. That's going to be positive again. No, because you guys just kept thinking. And I was like, well, they're not squaring. It's fine.
Would the entire time negative at one of them, because there has to be an
No change.
What did I do wrong? I should have had open intervals. But, hold on. Can't I put a... No, sine of 0 is 0. That needs to be open. Sine of 0 is 0. That needs to be open. Sine of that... Yeah, why can I close the 3? Because 3 is in between its zeros. Ha-ha! I need to close that one. If it was a long answer, yeah, they take off for the non-closed. Do you guys get the closed, though? Because that's a 0, that's a 0. 0, that's not. Oh, it's positive at 3.
Would it be as bad as would you just not get a point?
Yeah, you would lose a point.
Oh, great. So the entire answer's wrong?
Well, if the entire answer is only 1 point, hopefully it's not just 1 point. Because increasing, they would give you a point for the derivative. They would probably give you a point for critical numbers. Actually, I'm not sure about that. You might lose half the points. Letter C. Average value. What's the formula for average value? Better know it for tomorrow. Yeah, 1 over b minus a times the integral of a to b. So we have 3 minus 0 times the integral 0 to 3 of... Wait a minute, this is weird. What are they actually asking me to do? Ooh. If... Who's K?
use the MBT for integrals. Oh my god.
Hey, smarty pants, who's K?
Constant.
Yeah. But what does the problem say K is?
In terms of K. Oh, it's our little x.
Is it really as easy as this? So the average value I was able to set equal to K, and they said solve for this in terms of K. Well, how do I get that alone? Oh, times 3. Dun, 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 dun. All right, cool kids. You were working on your review this weekend, true? You were supposed to work on your review this weekend, true? Okay, well that's fun. Test day, yes. Yes, that's true. In your review, I am here to help you. Pourquoi, pourquoi? What's at the end of your review? 58 to 60. Guess what's here? Guess we're going to finish class doing your homework. All right. What kind of homework? The hard part. You guys ready? You and me, I don't mind us doing it together. I'm not sure if you want a competition. What if, wait, didn't you guys start the review in class on Friday? Didn't we have a work day? Oh, you came at the end. If you want, you can put a little box in the middle of wherever you are and do 58 to 60, and then you can keep going. Or you could write it somewhere else, or you could just pay super close attention and have to write it all later. It's up to you. So if you're in the middle of your review, why don't you just throw it in there, but put a big old box around them when you finish them. Or you can do your homework backwards if you haven't even started the review. Or you can do it in the back of your homework spiral and copy it down later. Sound good? Okay. Where are we at? You may use a graphing calculator. Isa, bring your graphing calculator tomorrow, bud. Everybody else, bring it. You probably can use it. We shall see. The rate at which water flows out of a pipe is given by differentiable function r of t. And we have data. There it is. Use a trapezoidal rule with 6 subdivisions of equal length. Ah, spoiled, rotten. Explain the meaning of your answer in terms of water flow using correct units. Water flow using correct units. I'm going to go ahead and real quick, just for sake of poor kids who are not here today. Ooh, that's not helpful. I'm going to do this. I'm going to do that. I'm going to do this. And I'm going to do that. And I'm going to do that. And then I'm going to do this. And I'm going to do that. I was going to work it on the whiteboard, but since not everyone's here, sorry. Okay. What do we got? What are our bases going to be if all of them are equal? Oh, wait. Yeah, can't we just go by fours? How many subdivisions? 1, 2, 3, 4, 5, 6. I think it's just natural to the table, so we can just go by fours. Well, there's only 6, and then they told me 6. If they told me like 3, I'd have to jump for every other one, like for a midpoint sum or approximation. I'm going to do 9.6 plus 2. Oh, guys, isn't this like what we just did? What's the nice thing is it's a long answer, so we're just going to box it when we're done, yeah? When do I stop doubling? Yeah, the beginning and the end. Wait a minute, there was more to this than this. Struggle. They said using correct units. Using correct units. Yes. Because this is approximating an integral. An integral taking a rate of gallons per hour is going back to some sort of change in gallons. Hey, we're supposed to explain the meaning. So couldn't we thus say that the amount of water kind of displaced, I don't know if that's the best word for it, but out of the pipe, you're welcome. In 24 hours above in gallons. Dun 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 dun. Weird. There you go. Okay, letter B. Is there some time between 0 and 24 such that r prime equals 0? Ooh. R prime equals 0? Yes.
It gives you the r prime, so then you change
Because the sign is current.
Wait, no, is r the...
That's r.
Oh, shit.
Needs r prime.
Oh, so never mind.
I'm not going to put all the wording just because, for sake of time, but can't I say at least once in 0 to 24 specifically? In 8 to 16. R of 8 equals R of 16. So must exist theorem. It's a derivative, so can't use IVT. IVT just tells me R goes between all those, but MVT, more specifically Rolls, would tell me, hey, if it starts and if it comes back, continuous function, which motion always is. A derivative equal to 0. It's specifically Rolls, right? F of A equals F of B. But to start and to come back, it must have some sort of smooth turn.
In the first part, it's 24 hours is approximately
The amount of water that flowed out of the pipe in 24 hours is approximately the above amount. The above amount, yeah, in gallons. I would put something like which approximates the amount of water if I had taken more time with it. Letter C. Ooh, I have a function. Go team. What do they want me to do with that said function? Suppose the rate of water flow is approximated. What do you mean add? Oh, average makes so much more sense. I was like, what are you adding? Use Q of t to approximate the average rate of, average rate. And that is a rate, right? Pause. Why is this dangerous? What have I trained you to think every time you see average rate? F of b minus f of a all over b minus a. But if they say find the average rate and they give you rate, then what are you doing? Average value. So 24 minus 0 to 24 of q of t dt. What did they say you were allowed to use in the problem? So what are you going to do? Plug it in. But what are your units of measure? Gallons. And then what's the warp rate? Yeah. You have chug. Okay? So what do we do given a table? There might be a theorem that comes up, MVT, IVT rules. There might be something to do with using the table to do some sort of Riemann sum approximation. There might be some sort of like, hey, here's a function, do more. Always with analysis every step along the way.
So are Q and T and R the same thing? Or is Q of T bigger?
Well, it says approximated by. So this is just a table. There is no specific function necessarily attached to this. Does that make sense? They represent the same, but this, probably my guess is that if you were to actually plug in time, it would not always exactly match up because most models that are trying to predict or to model, I keep saying the same thing. Most equations that are used to model situations are usually just approximations. Does that make sense? Yeah. So all the values wouldn't necessarily match up, but they are modeling the same thing. This is like the actual data points, and we're trying to approximate stuff with it. And this is saying, I think this is the closest model that approximates. 59. Oh, do we need? Oh. What do we know? It says find F. We know all these clues. This looks fun. It's like a puzzle. Well, I see F prime. What do we do with F prime? So we could go ahead and say, okay, f of x is equal to the integral. We could keep it indefinite even though it's kind of cheating, right? Wait a minute. They gave me another clue. Oh, that's the integral of f, though. They gave me a value of f prime. They gave me a value of f double prime. Keep it indefinite just because we know how to do indefinite integrals, right? Okay. So we get a over 3 x cubed plus b over 2 x squared plus c. Well, how do I use these? Can't I plug into the they gave me at the beginning? That'd be a times 1 plus b times 1. Ooh, how do I find the second derivative at, x? Who's the second derivative of x? That equals 6. Set what equal? I wish if it was 1. What else do we know? I mean, we could substitute. The problem is we could get a in terms of b, but we still have an x, right? Well, we still have a third clue. What's our third clue?
I don't know what to do with that. The integral of
I mean, we could do that, right? That'd be a over 12, true? X to the 4th. Plus b over 3 times 2 is 6. X cubed plus cx equals.
C. What are you supposed to do with C? More variables.
What's my other variable that's messing this up? But how many equations do I have? Ooh, except we don't know what to set. We would be fine, because if we have 3 unknowns and we have 3 equations, we'd be okay. The only dilemma is this guy, because we don't know what to set that guy. Huh. Maybe I'll have to play with this one. Disregard. If we had one more number, right? Like if this one was at something, that would be good. Or if they gave us like an initial of F, but they didn't. Did I miss something? I was thinking if we take the derivative, but the problem is, ooh. What if I had, oh, I don't think that was going to help anything. I was thinking if I had written him as like f of 0 plus 0 to x, and then I could take the derivative of both sides, and that would also be f. But the original that way. Start anywhere you want. I just don't have an initial clue.
Wow, this is like the hardest AP problem.
I think, yeah, this may be the hardest problem.
This is so funny. No, there was one similar to this on the mock AP last year. It just wasn't quite as involved. Because you guys didn't like it. There were like 3 parts to it, 2 or 3 parts. Yeah, Kathy.
I made it start. Okay, so I didn't get it, but I made it start from like, you know how you can use like the addition rule to like, well, kind of get.
Go from A to B and B to C. Yeah.
So I was going to like somehow make it so that it included the 0 and then get like the f antiderivative of f of 0, and then somehow make that so it only had like one equation, but I couldn't figure out if that's what we wanted to do.
F of 0. Because you're thinking like 0 to 1 and 1 to 2, something like that, like 0 to 2. That's actually a good idea. Because of number 59,
Yeah, that's a key calculus.
this is definitely on the test tomorrow. No, it's not. It's not on the test tomorrow.
Okay.
Wait a minute. Oh no, we didn't get to number 60. But we did one in class and you did one in homework and you guys are fine. You guys got this. I got one of the long AP ones done. I'll play with it. I'll play with it. I might start all, okay, fine. 59 is extra credit. How about that?
Thank God. I can't do that. I can't do that.
Just put a question mark.
I'm going to put a big
You
question
party poopers. I don't want you to agonize over it, but still.
mark. I have plenty of stuff to agonize over. I don't even want to agonize over 59.
You're welcome. Man, what clue did I miss? I think I need to start all over again. Yeah.